If you watch any of the other segment or angle proofs, hopefully you'll notice that they're pretty similar and start picking up some patterns. I'm going to write this proof in a flowchart, but then show you what the 2-column proof would also look like. First we have the given, which also means that the measure of angle 1 is equal to the measure of angle 3 by definition of congruence. Now we want some way of including angle AEC and some way of including angle BED. If you look at the picture, angle AEC is made up of angle 1 and angle 2. The measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. That's called the angle addition postulate. So now we have our AEC in the problem. We also need a BED. BED, that's made up of 2 and 3. So the measure of angle 2 plus the measure of angle 3 equals the measure of angle BED. Also angle addition postulate. I would underline what you need to keep in the problem. We want to keep a BED and an AEC because we're trying to have that left at the end. So we want to get the entire other sides to equal each other. Right now they both have an angle 2, but this is an angle 1 and this is an angle 3. So we can change either one, either the 1 to a 3 or the 3 to a 1, because we know that they're congruent from this step. We assumed that angle 1 and angle 3 are the same. So I'm just going to change this one. The measure of angle 3 plus the measure of angle 2 equals the measure of angle AEC. And that was by substitution. And I'm going to flip around those terms on the left. The measure of angle 2 plus the measure of angle 3. Because now it exactly matches the left side of this one. That was the commutative property. So now we can combine the whole left sides both equal each other. We can combine this into one equation now. So the measure of angle AEC is equal to the measure of angle BED based on the transitive property or substitution, and therefore AEC is congruent to angle BED based on the definition of congruence. So here's a neater proof of what I just did, and here's a 2-column proof.